There are 6 quantum computing modalities competing today. Each uses different physics, faces different scaling problems, and has different commercial economics. 3 or 4 will probably ship at scale. 2 are nearly certain to lose. This is video 2 of our quantum series, which physics actually wins. Why does the modality choice decide the winner? Same qubit, different physics means different fidelity ceilings, different gate speeds, nanoseconds versus microseconds, different coherence times, milliseconds to minutes, different connectivity, line versus all-to-all, different scaling paths, different fabrication dependencies. Same qubit, different economics. Superconducting needs dilution refrigerators near absolute zero. Trapped ion needs vacuum and lasers. Photonic works at room temperature. Neutral atom is reconfigurable. Topological, if Majorana works, you skip quantum error correction entirely. Annealing is a different problem class. Fault tolerance is now engineering, not physics. The path differs by modality. Here is the framework. 5 axes that matter. Fidelity, 2-qubit gate error rate. The fundamental question of whether the modality can cross threshold. Speed, gate operation time, determines how deep you can run a circuit inside a coherence window. Coherence, how long the quantum state lasts. Scaling, physical to logical qubit overhead and the fab path to thousands of qubits. Connectivity, which qubits can directly entangle. No modality wins all 5. The question is which trade-offs are commercially fatal. Modality 1, superconducting. Microwave-controlled circuits on a silicon chip in a dilution refrigerator near absolute zero. Strengths, the fastest gates in the field, 20 to 50 nanoseconds. Chip fabrication leverages the semiconductor industry's existing toolchain. The most mature physical platform. Weaknesses, coherence is microseconds, the worst of the field. About 1,000 physical qubits per logical qubit with surface code. Requires extreme refrigeration. Nearest neighbor connectivity only. Milestones, Google Willow validated below threshold. IBM's Nighthawk has 120 qubits. Kookaburra coming in 2026 with quantum LDPC codes. Rigetti Cepheus 108 qubits, 99.1% 2-qubit fidelity. Public exposure, Rigetti as the pure play. Alphabet, IBM, and Amazon at the megacap level. Modality 2, trapped ion. Individual ions suspended in electromagnetic traps. Qubits encoded in atomic energy levels controlled by lasers. Strengths, the highest fidelity in the field, over 99.9% on 2-qubit gates. Coherence runs from seconds to minutes. All-to-all connectivity in a chain. Every ion of a given element is literally identical. No fab variance. Weaknesses, slow gates, microseconds, roughly 1,000 times slower than superconducting. Hard to scale beyond about 100 ions per trap. Vacuum and optical control add complexity. Milestones, Quantinuum's Helios processor, 99.921% 2-qubit fidelity in November 2025. The 94 logical qubits result with iceberg codes in March 2026. IonQ first quarter 2026 revenue $64.7 million, up 755% year-over-year. Public exposure, IonQ pure play. Honeywell as the megacap through its Quantinuum subsidiary with an S1 already filed. Modality 3, photonic. Qubits encoded in single photons routed through waveguides. Operations performed by beam splitters and detectors. Strengths, room temperature operation. Chip fabrication borrows from the photonics industry. No dilution refrigerator. Network native, photons travel. Weaknesses, photon loss kills the logical state. This is the hard problem. 2-qubit gates are probabilistic, not deterministic. Sources and detectors are complex. Milestones, PsiQuantum raised $1 billion at a $7 billion valuation in 2025. Silicon-based fault tolerance thesis. Xanadu went public in March 2026. Photonic plus Penny Lane software. Quantum Computing Incorporated pivoted to entropy computing in photonics. Public exposure. QUBT and Xanadu, both pure play. No megacap pure photonic competitor. Modality 4, Neutral atom. Atoms held in arrays by optical tweezers, focused laser beams. Gates performed via Rydberg state interactions. Strengths. Long coherence since they are atoms not ions. Flexible reconfigurable qubit layouts. Native mid-circuit measurement. 100 times overhead reduction demonstrated by QER in 2025. Weaknesses. Less mature than superconducting or trapped ion. Complex optical control infrastructure. Fewer publicly published gate fidelity records. Milestones. Inflection went public in February 2026, the first public neutral atom name. QER received $230 million from Alphabet with fault-tolerant operations at scale. Pascal plans 10,000 qubits in 2026. Atom computing remains private with demonstrated fault-tolerant operations. Public exposure. Inflection only public. Pascal, QERA, and Atom remain private. Modality 5. Topological. Information encoded in non-local topological states, Majorana 0 modes. The state is protected by physics, not by error correction codes. Strengths if it works. Intrinsic fault tolerance, meaning no QEC overhead. Far fewer physical qubits per logical qubit. Could leapfrog every other modality. Weaknesses. The hardest fabrication problem of any modality. Microsoft's 2018 Majorana detection paper was retracted, denting credibility. Still essentially pre-qubit at scale. Single company bet. Milestones. Microsoft unveiled the Majorana 1 chip in February 2025, claimed as the first topological qubit processor. No public pure play exists. Public exposure. Microsoft only as a megacap. Highest risk, highest payoff path. Modality 6. Annealing. Specialized hardware that finds ground state solutions to optimization problems. Not general-purpose gate model computing. A different class of machine entirely. Strengths. The highest qubit counts in the field, over 5,000. Available commercially today. Real customer book on optimization. D-Wave runs an 83% gross margin on its annealing systems. Weaknesses. Not universal. You can't run Shor's algorithm on annealing hardware. Specialized to optimization. Quantum advantage on annealing is debated by the academic community. Milestones. D-Wave fiscal year 2025, revenue $24.6 million, up 179% year-over-year. Q1 2026 bookings up 2,000% year-over-year, adding gate model capability via the QCI acquisition. Public exposure. D-Wave only public, no megacap competing on pure annealing. Side by side, where each modality wins. Superconducting, good fidelity, the best speed in the field, worst coherence, good scaling, best for near-term universal quantum computing. Trapped ion, the best fidelity, the worst speed, the best coherence, good scaling, best for high-fidelity fault tolerance. Photonic, okay fidelity, very fast, best scaling, best for networking and scale-out fault tolerance. Neutral atom, good fidelity, medium speed, very long coherence, best scaling, best for flexible large-scale workloads. Topological, intrinsic fault tolerance, but speed and scaling are to be determined. If it works, it dominates. Annealing, 5,000 plus qubits, optimization only. No single modality wins everything. The market is hedging. Realistic probabilities. Superconducting, near certain to ship. Validated below threshold by Alphabet and IBM at scale. Likely role, general purpose fault tolerance. Trapped ion, near certain to ship. Quantinuum and ion Q at extremely high fidelity. Role, precision workloads. Photonic, competitive by 2028 or later. Psi-quantum plus Xanadu on the silicon fault tolerance path. Role, networking and scale-out. Neutral atom, strong dark horse. QER and atom computing with the 100 times overhead reduction. Role, flexible workloads. Topological, 30 to 40% odds in our handicap. Microsoft must repeat Majorana 1 at scale. Role, wild card disruption. Annealing, already winning its niche. D-Wave with the commercial revenue book. Role, narrow optimization. Smart money, hedge across modalities. Skip topological, unless you can size for zero. The public investment map. Superconducting, RIGET as the pure play, Alphabet, IBM, and Amazon as megacap exposure. RIGET is the high beta tech bet, trapped ion, IonQ pure play, Honeywell via Quantinuum at the megacap level. Honeywell pre-IPO is the cheap hedge, Photonic, QUBT, and Xanadu as the two pure plays, no megacap exposure. Neutral atom, inflection only pure play. Watch Pascal, QERA, an atom for private to public transitions. Topological, no pure play exists. Microsoft sole megacap providing cheap optionality. Annealing, D-wave only. 5 of 6 modalities have public pure play exposure. Topological is the Microsoft-only exception. Verdict, diversified modality exposure beats single bet. 3 things to take away. Superconducting plus trapped ion ship near certain. Neutral atom is the strongest dark horse. Topological is binary. Skip if you can't size for 0. Mapping to our picks for videos 4 through 7. RIGET is the superconducting beta exposure. D-Wave is the annealing commercial book. ARCIT is post-quantum encryption, modality agnostic. Honeywell is trapped ion via the Quantinuum subsidiary. Up next, video 3, the technical scan, is the basket tape ready for the move? Relative strength versus the S&P 500 and the semiconductor index. Sector regime check, not entry signal, research opinion only, not investment advice. Do your own work. Next, video 3, technical scan, cortical flow.